It's massively, massively used online to create fake social media profiles. So on Twitter, you can see them everywhere. And now that I've been working on them a lot, I can recognize them very quickly. But this is very important to have a system that can allow us to detect. For the people in the back, we have a lot of seats open in front. Don't worry, I won't bite. So this person does not exist.com. It's a demonstrator of something, a neural network called StyleGAN2. And it's what it says. It's a generator that generates faces in that case. StyleGAN2, it's a network made by NVIDIA. They made the model public, and some guy decided, yeah, let's create a website where every time people refresh, it generates you a new face. So we are going to use that also as an excuse. So I can explain how this kind of system works, because it's super interesting and it's not as complex as you may think. So I was saying the social media profile stuff, it's a big thing. Yeah, it's because this kind of website, this kind of AI model made a very strong barrier fall. Because before, when you wanted to create a fake profile, well, it's easy to make a fake username, fake name, credit card numbers even, we have generators. But the picture is always very hard. Either you put something abstract and the profile is less trustworthy for scammers and stuff like that and political influence, or you put someone else's picture, which oftentimes can be found with reverse image search, and so you can always tell that this is a fake person. But now with that kind of generators, you have one-time pictures that can be reused, and so I wanted to be able to tell apart people who have a fake profile from legitimate users. We have the luck that StyleGAN2 is hard to train, and scammers don't really want to go through the entire effort of deploying their own model for faces to just generate a few fake profile pictures. So they will luckily use thispersondoesnotexist.com pretty much every time. So if we manage to kind of hack that website, it would be a very good way to discriminate between fake and real users. First, I want to talk about how the system works, how this AI works, because I find it super interesting. It's called StyleGAN2, and GAN is very important term in there. It's one kind of neural network. So who knows here how neural networks work? Okay, yeah, kind of, maybe less than half of you. Okay, I won't this is a 6 months university course. I'm going to do that in 5 minutes, so bear with me. This is a neural network. It's a kind of a black box. You can train it to do whatever you want, pretty much, based on inputs and outputs. This is a mathematical function. Those circles, they are numbers. These arrows are additions and multiplications. That's basically it. You can, so the training is done via slightly modifying the way it does its multiplications and additions, but you can train it to perform whatever task you want. And that's what you have to remember. The neural network is just a small brain, a small black box function that you can train to do whatever you want. So a few examples on that. Finding a plant species name from just a single picture. So here, the numbers you input on the left are the pixels of the image. The numbers you get on the right are the species name. It's a bit simplified, of course, but and you'll have way more parameters in there, but that's it. And that's an app called PlantNet, by the way. It's free. You can install it, and it's great for walks in nature. Detect what kind of plant is that, can find it instantly. A project I've worked on in the past, evaluating car damage from a video as well. For insurance companies, you want to not have to deploy an expert every time, have a pre-assessment made by the machine. Another kind of task on multimedia neural networks is on audio, and it's super interesting. It's, for example, determining when someone says that 2 words that I'm not going to pronounce to not trigger your phones. And another very interesting project that I worked on is using neural networks to work on network traffic and detect suspicious stuff. So in cybersecurity, it's also there's also a big rise in AI to kind of replace the humans and perform the most simple tasks, to put it that way. So yeah, there's a lot of examples, but as you can see, there's always like an input and an output, and we train the network to do that. So now what's a GAN? What's that kind of network that can create images out of the blue? Because it's pretty hard. Most of those things, you just provide it with a lot and a lot of examples. That's how you train the network. But how really would you train a network to create faces that don't exist? So generative adversarial network, it's a kind of network that was invented in 2014, so it's pretty recent. The peak of that was in, I think, 2021. Now we are more in diffusion models. So if you have DALI, if you think about Stable Diffusion, Midjourney, stuff like that, it's diffusion models, and they are working in that kind of new generation. But GANs are pretty easy to understand how they work, and that's how this person does not exist works. In a GAN, we have actually 2 different networks. So remember, a neural network is just a black box. We are going to train those 2 black boxes to work together, actually against each other, to produce something. So we have the generator, that's the network that interests us. The input for it, it's a bit special. We just provide it with random data. It's because, you remember, a neural network is just a series of additions and multiplications. So we have to provide it with some random data, otherwise the output would be every time the exact same. Since it's just deterministic operations, there is no randomness in there. So the randomness we provide it, so it's a source of random numbers. So we usually have like 500 numbers that we provide in there, and it derives that, and the output, we want a full image. So the output here, we are going to have like millions of numbers, and it's the pixels of the image, R, G, and B components. And that's basically it. We want the generator to do that stuff, so generate realistic faces. On the other hand, we have the discriminator. Its job is to determine, given a picture of a face, whether it's real or not. And when I mean not real, it's generated from that guy. So the discriminator's job is only a binary classification. Is it real? Is it not real? And then we're going to play a game where those 2 networks are against each other. So I'm not sure where I should stand so the mic doesn't feedback. We'll try. So we have games where we pick an image randomly. Either it's a real image from a real faces dataset. We're going to come to see what that dataset is made of a bit later. So either we pick a random image from that dataset, or we pick an image generated by our network, our generator network. And the discriminator, it has to determine whether or not it comes from the generator or the real images dataset. And that's a game we play a lot and a lot. And over time, they will get better, because this kind of training I was talking about a bit earlier, it's a bit obscure, but you can kind of reward a behavior of a neural network to perform what you want. So initially, it's completely random, and then over time, the neural network gets better and better to perform the task you want it to perform. So they will play against each other. Each of them is going to try to beat the other, so which means for the generator to make the most realistic faces it can, and for the discriminator, it will be to find telltale signs that an image was made by a neural network. So initially, you will actually have, here it will be just white noise images. The discriminator will just output yes and no randomly because they have no reference at the beginning. And then over time, well, by random chains, they will randomly stumble upon a bit better state, and they will be rewarded for that. So for example, the discriminator, which is more simple than the generator by the nature of its task, it will, for example, detect that if all the pixels are kind of random noise, well, of course it has to be the generator. If there's a bit more structure in the image, it's going to be a real image. And so now the generator will catch up. It will try to, it will tend to produce images with more structure, and then it will produce faces. Like we as humans, we obviously know this is not a real face, but they will tend to get better and better and better, and at some point they will imitate almost perfectly real images. We have some difficulties, so I mentioned training and deploying your own GAN is very hard. The main difficulty for any kind of neural network with a training dataset is overfitting. It means that your classifier, so for example here, the discriminator, it will learn perfectly what this dataset looks like. And so now, well, it's basically a lookup table. It says, well, yeah, this image is real. I know that because I've seen it like thousands of times, and now it has learned it by heart. So it's not useful anymore, and the training is gone, and the GAN is all bad. The generator will just try learn how to replicate real images, and that's absolutely not what we want. So this is one of the issues. It's illustrated there. We want a line to classify, like a frontier to classify. The black line is actually better, even though it doesn't have 100% performance. On this training data, yes, but on real data, it will perform much better than the green line that's 100% on the training. GAN is also super slow to converge, so it means that it takes a lot of time and a lot of training games of generator versus discriminator to train. One of those reasons is, you can see here, the generator, it never sees what a real image looks like. It can only guess, try to make guesses, and if the guesses kind of look like faces, okay, they will get rewarded, but they only get their information through guessing. And guessing what a real face looks like, so it's very, very slow. And that's kind of an issue that's been somehow fixed by the neural diffusion models in DALI and stuff like that. We also have so the issue of computing power, which goes with the slow convergence, because neural networks are trained on GPUs usually, which cost a lot. They take a lot of power as well to compute. You need a lot of GPUs in parallel to train a model. So that's also one of the reasons that usually you tend to reuse an existing model instead of making your own. There's also one fourth issue that's specific to GANs. It's called mode collapse. It's a bit complex, but it kind of looks like overfitting. Look it up, it's interesting if you're into that. So, now that I've mentioned how GANs work, we want to detect those kind of images. So what do we do? Could we create an AI model that detects, that gives us a yes or no based on an image that says, yes, this was generated by an AI, no, this is a real image? Well, if that were the case, if we could make a model that does that kind of decisions more than like random, it means that we have created a discriminator that's better than the one used in training. And Style GAN, it's made by like a research team of top engineers from NVIDIA, so I don't believe I could compete with that. So we're going to have to find some other way. We cannot build a discriminator, we cannot build an AI model that's good enough to detect that kind of stuff. So, well, that's kind of a problem, right? But I said GANs are based on a game, so let's try to cheat. We have two ways to cheat in that game. Either we kind of find a flaw in the rules of the game, or we can also find a flaw in the game entirely. And we're going to do both. So let's play another game, especially if you know the website. So this person does not exist. As a reminder, faces look like this, okay? I mean, there's some intuitive stuff that works and that can help us detect whether or not a face is real. So now I want to ask you which one is the real one. So this should be a bit easier. Who thinks it's the person on the left that is the real person? Okay. Who thinks this one is the real person? Okay, so as you can see, now you are very good at that. So what's the difference between those two pictures and those 9? Well, there's a lot of indicators. Let me just find that. So first, the pose. Open mouth almost never happens. Like face tilted to the back, the background, the shape as well. It's a rectangle. On this person does not exist. It's always a square. There's a lot of things. And there's, well, that's a lot of intuitive things. But actually, there's one that's super important. But first, let me talk about the dataset that was used to train StyleGAN. So this is all real people coming from a dataset called FFHQ. That's what was used to train the neural networks. There's about 70,000 pictures. It comes from Flickr, and it's all like open source pictures that have been cropped automatically to fit squares. And so those are the people that were used to train StyleGAN 2, and this person does not exist. I'm not sure if you noticed something in that previous video. Now let me add the laser eyes. As you can see, all the faces, all the real faces of humans in the training dataset have been cropped so that the image is always like 1024 pixels by 1024, and the eyes are always in the same position. It's actually something the creators of the dataset wanted because it makes it a bit easier, it normalizes the dataset. But since StyleGAN 2 will try to imitate those faces, it means that it also has this specificity. So let me show you here. You can see the eyes, again, of our deepfakes. The eyes are always in the same place. Because, and it's due to that game, because if it ever tries to create a face with the eyes not at that exact same place, well, the discriminator will know, because the position of the eye, if the discriminator sees the eyes that are some other place, it will say, no, it's not a real person. It's obviously coming from the generator, because all the real pictures are from have those eyes in that same place. So that's a good like pre-detector. If you find a profile picture on social media that has these eyes at this place, very specific, and it's not as common as you think in real people. I invite you to try, go on Twitter and check. People rarely have their faces like that up close with the eyes at the same place. So that's a good technique to pre-detect. But that's not the most efficient detector in the world, right? By the way, this technique is not new. It was, I'm not sure who originally found that technique, but it's like inherent to the neural network. Now what I'm going to show you next is one technique that I designed, and it's super efficient due to a small hack. So now we're going to try that second technique. So here's a small script. What it does is it downloads, it refreshes the page in a loop. So it takes those images, downloads them in a loop. And one thing I realized is that, yeah, we download the image, we compute the hash of the image, and we print just a few characters at the beginning of the hash. Pretty simple. This is just to demonstrate something. You can see, like, second and third line, actually the image that the server sent us is the same, twice. Here it's the same 3 times. Here twice again, we have duplicates. So we can see that if we refresh the page very quickly, we get actually sent the same image. And I tried this like from 2 different IPs over the world, and actually the images also are the same. Which means that basically wherever you are in the world, if you query thispersondoesnotexist.com at the same time, you will have the same image. I think it's to save some computing power to the poor guy that owns the website, because if someone decides randomly to generate like 1,000 requests per second, it will cost a lot in cloud costs on GPU. So now it's just a background job that just updates a local image once about every second, once every 1.2 seconds. And it's the same image that is served to everyone. So it's kind of a global cache. That means that, well, the image, if someone were crazy enough to download all these images, to run a script that downloads all these images every second, well, we could build a database with all the deepfakes ever generated by this person does not exist. And well, this crazy person is me. I've done that. So yeah, that's... by the way, my internet provider may be not super happy with my bandwidth 24/7, but so far I'm good. So the structure of this project is quite simple in its structure. So we have this person does not exist. 50 times a minute we query it with a script that very much looks like what I've shown you here. It's a while through loop and download the image, and that's it. And then I have my hard drive at home that just stores all these images. Actually, we don't exactly do 50 queries per minute. In order to not miss any, I'm like more 200 per minute. So I download every image about 4 times to make sure that there's no gaps in the coverage. And then, well, once we have a suspicious profile picture on Twitter or Facebook or whatever that we suspect may be a fake profile, so a scammer, political influence, stuff like that. A lot of people have use cases for fake profiles. Well, we can do some magic with an image search script, so a script that just browses all that hard drive and finds matches. It looks easy, but actually it's much harder. Sorry, those slides are from a bit older, as you can see by the age of the meme. But when you look at the scale, when you look at the amount of data that comes in and that has to be stored, it's a bit hard because we have 72,000 new images per day. So that's about 1 per second. The JPEG from this person does not exist, it's about 0.5 megabyte. So if that doesn't look like a lot, but if you put that all together, it's 32 gigabytes a day, 11 terabytes per year. So this is a side project that I made at home. I'm not monetizing that. I'm not doing anything with it except just showing off, I guess. So I'm not going to the supermarket every few months to buy a new hard drive, right? Also, we have storage space, yes, and also lookup time. Because we want to find matches in a hard drive full of images, we could compute the hash and just store the hash and do lookups with that. But actually, social media compresses the images. So we don't have, if we do a cryptographic hash like a MD5, SHA-1 or whatever, it's not going to match any images we send to that searching script, because the hash is modified by the compression that's proprietary to the social platform. There's also another issue. If the person with the fake profile decides to, for example, flip the image, we don't have the... It's super easy for them to do, and now all our hashing, everything goes to the trash, and we have to anticipate everything, cropping as well the image, adding a filter, whatever. They could do a lot of modification, very small modifications that keep the face, so the profile is still kind of trustworthy to someone who doesn't know, but our detection loses. So I don't want any of that. But, so I want the best of both worlds in there. So I want very high recall rate, but also very low storage space. My hardware constraints for the project. If you don't know that, it's called a Jetson Nano. It's basically a Raspberry Pi on steroids. So yeah, that's the $100. It's actually a bit more, but I got that for free. So I guess the cables and the SD card are about the $100. You can see the constraints. 4 gigabytes of RAM, slow CPU. We have a GPU though, because it's kind of a prototyping platform for neural networks. It's made by NVIDIA, them again. And so we have these constraints on storage that are super important, and I didn't want to exceed budget by going off of that machine for the beginning of the project. So, so I said we cannot afford to use hashing because it will destroy the recall rate of our matching algorithm. But actually we can use something called visual hashing, which is you send a picture of a face and it will give you a hash. And this hash will represent the face in some way. I was using the network FaceNet, but there's also PhotoDNA for pictures. For example, PhotoDNA is developed by Microsoft especially. It computes kind of a hash of a picture, and even if you apply transformations to the image, as long as the picture looks about the same, the hash will be very similar, and that's what FaceNet does. So. If we plug in that neural network, 2 faces of the same person, even if like they have changed shirts, they have aged a bit, so the beard has grown a bit, they have glasses, and in the previous picture they didn't, still the hash will be kind of the same. So it's a neural network that will capture the features, the main features of the face, and not the details around. And similarly, we want also, of course, to have, if we give it 2 different people, even if they have the same background, they are both smiling, same shirt, same necklace, we want the hashes to be very different. So this network, it's a pre-trained network that I've downloaded online. It does exactly that. It extracts the feature of the face, and the hashes will be similar. They will not necessarily be identical because, well, it would be a bit far-fetched, but it gives you like kind of a similarity score between 2 faces. And since those are vectors, so basically arrays of numbers, we can also do kind of fuzzy matching and fuzzy indexing, so we don't have to look through all the index for a match. We can use something called KNN search to search for the closest vectors in a given database. So this is very good because now, instead of storing the image, we are just storing the vector. We are just storing the visual hash of the face. This is 2 kilobytes, so we have more than 200 times disk reduction. So now what we used to store like in almost a year, we can store in the same volume for a single day that we use before. And also, since this is based on a neural network, FaceNet is a bit, well, it's kind of a complex algorithm. It's a neural network, but we have a GPU on that device, so we can compute it very fast, even with our limited computing power. Yeah, to do the lookups, instead of having an index or having a linear search where we have to go through all the images to find matches, we have something called ElasticSearch Open Distro, which is now called OpenSearch. And it implements, so it's a kind of a spin-off of Elasticsearch, where there's a good plugin that can do KNN search for us, so find the closest faces from a given face vector. So now the program looks kind of like this. So we have this, still this person does not exist. We have the same script that downloads the images over and over. Compute now the hashes of the faces with FaceNet and index them in our OpenSearch database. And now when we have a suspicious profile picture, we just have to compute their hash with the same network and query the index to find the vectors that are the closest. And if we find a match, it means that this face has been seen before, so it was generated on thispersondoesnotexist.com while our script was running. Of course, I cannot predict in the past, but running the script long enough, usually like for a year, will cover 100% of the profiles because they usually get banned quite quickly. So we have bonus points on that because we are now, since FaceNet is very resistant, it's resistant to transformation. I mentioned to change of clothes, bit aging, stuff like this. So now if the attacker or our adversary is using a transformation method, so for example flipping the image before using that as a profile picture, this is a very common technique. Now, well, we don't really care. It's the same, pretty much the same vectors, who we will find that. Bonus point number 2 is that since every image on this website is generated randomly, there's a huge space. So it's like 512 dimensions. So kind of, I'm not really sure, but there's basically an infinite number of faces this network can generate, and they are all unique from that point of view. So if we find a match in our database, we can find when this face was indexed, and we can know exactly when it was generated to the second. So we can retrieve the exact time it was generated. It's sometimes useful to, for example, if we have a network of profiles that we suspect to be from the same owner, and we have like matches that are like 2 minutes apart, faces generated 2 minutes apart, well, that's probably the same person behind that, and they didn't go through the effort of waiting a few hours between to blur their tracks. So we can retrieve the date. So it's demo time. This is, as you can see, my achievement as a front-end engineer. No, I'm a Python guy. I don't know CSS. As you can see, the index is currently very small. It's because, for you, especially JFocus, I spent my whole night until 4 a.m. to migrate that to the cloud. So now the index is brand new and it's empty, but now the project will hopefully work more than just a few hours a day when it's not crashing and stuff, due to those constraints we saw before. So now I have like a big machine in the Google Cloud. Thank you, Google, for that, free credits. And but it should hopefully work. So what I want to do is I'm gonna download this face, for example. Yeah, you can see my downloads folder is full of them. Yeah, bit of a weird thing to explain when you're dating, and she's like, what's all those faces? So I'm going to upload that, and it will give us, so remember, we are storing the hashes of the faces. So our index is going to just do a quick match on the faces. Okay, let's hold our, oh yes. Well, it's my first try. So you can see we found that. So what I'm showing on the left is actually the picture that was stored. Why is it all blurry, you ask? Well, it's because, remember, I wanted to compress a lot. 400 kilobytes is too much to store on my hard drive. So I'm just storing a very small compressed image. So this image is actually compressed like nearly 300 times. So it's only a few kilobytes. But it's good to do a visual match, because if I just tell you through this platform, yeah, you have a 99% match with another image, there's no real way, like how much can you trust that number? But now I'm showing you that picture. I say, okay, I have this in my database, and you can confirm visually very easily that it's indeed a match. And also I give you the timestamp. Again, didn't really care to do the processing and show the date in a nice way, so convert it yourself. So yeah, and you can see those, it's the top 3 matches. They kind of look alike. You see, like, even if the background is different, we kind of have the same face. And this is out of an index that has only about 4,000 people, because I restarted it over the lunch break. But when it processes, like I used to have, I think 16 million faces in that index on my very small Jetson Nano. By the way, it's like a country scale facial recognition system that I've built. I'm very surprised that the army has not contacted me. But I mean, if I can do that in a few hours, just understand what they can do also. It's kind of frightening. And yeah, also one fun feature that I found is that you can send a picture of your own face, and it will give you like 3 deepfakes that kind of look like you. It's also a fun game. You have like to be really like front face and square, but it kind of works. And also even if the image is not in my database. So if, for example, it was generated while the script was not running, so basically before yesterday for that instance, I still generate the laser eyes to give you some sort of confirmation on non-confirmation that it's a deepfake. So yeah, that's the tool. It's only kind of a proof of concept. It's been used in some investigations to like confirm that someone is actually a real person or not, and mostly on politics. I'm not sure here, but in France, politics, there's a lot of weird accounts with that, and so it's always useful to call them out, like, bro, you have like a profile picture that was generated on that date on a deepfake website, so please stop giving your opinion. It doesn't count. Yeah, and sorry for people who want to remain anonymous. By using that, your opinion doesn't count either, apparently. So yeah, well, it's an older slide. So what do we put? 3K. Wow, impressive. Sub 10-second search. Yeah, I mean, that kind of fits. It should be sub 1 second. It's available for free if you want, so at this URL. Again, this, I can get rid of it since now we're in the cloud. Well, I'll do that later. And if you're not afraid to read code that's only backend and no CSS, it's also open source, and you can try to deploy your own at home if you want. I'll probably do an API version at some point, because there's been a lot of demand on that. Okay, so to finish, I gave you a good discriminator You remember what a GAN was? The discriminator is the network that tells, yeah, this is a real, this is a fake. Now I want to give you a good generator. Don't use that link, it's broken actually. Well, it works, but the thing behind is broken. What I want to show you is you can actually use StyleGAN too. So the network that's behind this person does not exist. It's actually public, it's free. It's a demo from NVIDIA, so they have trained their own, but you can download it and run it in just a few hundred lines of code, which is, I think, too much for a demo, but I think they've put it in a nice Python package now. Yeah, it's not running right now, but I can show you. You can generate your faces at home. And this will not be caught by my tool, because my tool only works for faces that have actually been spotted on that exact endpoint. So now, if you want to create your own fake accounts for political influence and stuff like that, it's all yours. Also, one very nice thing that you can do with this, I'm not sure it's there, yeah. You can generate variants. So you can see this is pretty much the same guy, right? But in a very slightly different pose and stuff. So if you want to use that network, you remember that there was like a random input at the beginning of the generator. The neural networks are a continuous function. So if you remember your math classes in high school, continuous means that if you modify the input a slight bit, the output will also be modified just a slight bit. It will not change like from everything to something completely different. And so now this random vector that we input to the generator, we can actually manipulate it, change just a few values, tune it, and so we can generate that kind of stuff and have completely new situations with pretty much the same person. So you can see on the left, he's a bit younger. It's useful if you want to have more than one deepfake that represents the same person, and to make it feel more realistic instead of just having the same profile picture everywhere. Thank you so much. If you have any questions, we have a few minutes. If you also want, so I mentioned at the beginning, Coding Game, we have hiring tests, automated hiring tests for developers. If you want an extended free trial, I have a link, and don't hesitate to go there. You have access to the whole question bank, which we don't usually give to free trialers because we're afraid of leaks. But now you have it all, and you have 1 month free for interviews. Thank you, and if you have any questions, I'm all yours now. There's a mic here, so...
Any questions?
Yeah, the first one is always the hardest.
Yes.
Thank you.
Hey, so, yeah, I thought this was really interesting, so thank you. And one of the things I'm thinking about a lot is, especially with the ChatGPT hype or whatever, it's about, yeah, if someone was to have enough capital to train a network from scratch, and like what your thoughts are from that, from both the, I guess, NLP and from the image. So then they could create like a really unique profile that's generating, all types of content, both language, videos, even possibly in the near future.
Yes. I think this kind of detector that I've just shown you is one of the last ones that we'll ever have, because the diversity in models and the way, like the telltale signs, are going to be much and much smaller. So, for example, ChatGPT, text models. So text is a bit harder to detect, but still, OpenAI has published their paper to detect their own from their own model. If it's from ChatGPT or not, the performance is absolutely terrible. So I think this is the end of the era where we can actually detect whether or not some content was produced by a human or not. It's scary. It also means that it's more and more realistic. So it's also hopeful. But yeah, it's that kind of detector is going away. And now we're going to have to live with the fact that some of the content we interact with on a daily basis, we don't know if it's human-made or not. Thank you.
Any more questions?
I'm a bit afraid to ask your question in front of everyone while I'm packing my stuff, and I'll stay here. You can come. I'm very happy to answer any questions. Thank you.